Hi, my name is Everett Shen. I'm a senior in the Coast Department, and today I'll be presenting StreetView360X, which is my project for generating 360-degree street views using a latent diffusion model using a location-based prompt. So, to explain what that actually means, this here is a street that doesn't actually exist in the real world. It's a fake image, which is generated by my model. So my project, in a nutshell, is basically think a Midjourney or a DALL-E, but specifically for generating street views, like the kind you'd see on Google Street View, using a single location. So this here was generated with the prompt StreetView360 Canada, and it's supposed to be Canada. So yeah, that's my project. To introduce the motivation, in recent years, VR and the metaverse have become more and more heavily funded and researched topics. It's going to grow a lot in the next 10 years, and with that, it's going to come a lot of increased demand for VR assets. With the metaverse comes the promise of infinitely auto-generated worlds, so think No Man's Sky or Minecraft, but that's going to be a very labor-intensive process that's probably not going to be scalable with current methods. The good thing is that this has all coincided with the rise of generative diffusion models. So diffusion models have kind of become the state-of-the-art method in generative AI for creating kind of image or video content. And the question is, can we combine all these technologies together to create some cool content? The problem with directly using diffusion models right now to create VR media is that VR assets can be pretty large, so it's pretty resource intensive. There's not that much data out there, so it's currently relatively harder to do. So during my research process, I was kind of looking for some way to kind of bridge that gap and kind of serve as a stepping stone. And I landed on street views because street views are a pretty widely available source of data. They're pretty high quality due to the capture methods, and they're pretty close to VR media. Like, you can view them directly in VR seamlessly. And it's also just a pretty interesting topic in and of itself, given that you can, draw a lot of cultural conclusions from various street views from across the world. So my goals for my project were to see if we can learn a diffusion model for generating specifically 360-degree panoramic street views, if it's able to capture those properties, and hence kind of serve as a prediction for how well it will generalize to VR. And then another big goal of mine was to be able to prompt this model directly using the location name, like India. Right now you kind of have to use kind of a more freeform text prompt, like a street with cherry blossoms and mountains in the background, instead of just saying Japan. So that would kind of allow us to answer the question, what does the average street in like Colombia look like based on real world data? Because we're training this with real world data, so it really will kind of be like an average of every street in Colombia. Potentially, we could use the outputs of this model for training self-driving cars, training people for GeoGuessr, because that's a pretty popular game now, or even creating new maps for that. And also, I think there's a lot of interesting studies to be done for urban planning or cultural studies with the images generated with this model. So to explain how a diffusion model actually works, in a nutshell, it works by taking random noise, so over here, and then iteratively using a model to predict how much noise to remove to get the next one, and doing this until you get the final image. So training is reversed. You start with the original image, you deterministically add noise, and then the model is supposed to basically be able to learn how to predict how much noise to remove at each step until you reach the original image, basically maximizing the probability of the original data set. Stable Diffusion is probably the most popular open source version of a diffusion model. It was launched in 2022 by Stability AI. It's open sourced, which is great, so anybody can fine tune it. It is trained on a 5 billion image data set, so it has a lot of information about the real world and visual information in general. There have been other works targeted towards generating panoramas using diffusion models, notably LDM3D Pano, and which is developed by Intel, and Text to Light. They're both kind of for generating these kind of high quality panoramas. They're pretty great. The problem is that they're not necessarily equirectangular images, so you can't really necessarily drop them directly into VR. They're more general purpose, so not only for street views, and also they don't have any location knowledge, so you couldn't just say, I want a picture of India, and then get a picture of that. It wouldn't be very accurate. I also have to introduce this concept of a equirectangular street view, which is kind of what we're trying to go for. Imagine you have a sphere and then you kind of flatten it onto this flat surface, leading to kind of this distorted top and bottom, whereas the middle looks normal. But if you drop this into a 360 viewer, it'll look like the real world, basically. And the biggest source of data for this is Google Street View. So how do we actually do this? I split it into 4 steps. Number 1, create a data set of street views randomly sampled from Google Street View. Caption each image with its capture location. fine-tune a checkpoint based on Stable Diffusion, and then kind of generate images with it and evaluate the performance. This is a map of Google Street View coverage worldwide. As you can see, a lot of countries have very sparse data or none at all. We kind of use that to inform how we would collect data for this. So half of our images are kind of just like randomly sampled. The other half is for each country with Street View coverage. We would try to get a minimum threshold of countries, of Street Views. This wasn't always successful, but we tried our best to get like as many Street Views for each country as possible. So this is the final distribution, and then we will be publishing and making this data available on Hugging Face. So that's one of our contributions as well. We would then caption each image with its address, which we got using the Google geocoding API based on its coordinates. So we got the country, continent, and region. And then for training, we used EveryDream2, which is a open source fine tuner for Stable Diffusion. So it kind of abstracts away a lot of the complexity. But it's great because it allows you to learn based on flexible aspect ratios. So Stable Diffusion itself is trained to generate 1:1 ratio images, whereas we need 2:1 for a Street View. So EveryDream2 seemed a lot more suitable for that. It also, because it's better for kind of training big updates to a model instead of just like smaller conceptual ones, we're kind of basically training an entire new class of images. So for that, it seemed pretty fitting. In terms of the details of training, we trained at a 768 by 1536 resolution. 768 is the native resolution for Stable Diffusion, so that was a reason. But also because we knew that we could upscale later with various upscaling AI technologies. But it was determined that 768 was basically kind of the best resolution to train at, even though that is somewhat lower than what you want for a Street View to seem immersive and high def. But we determined that we could upscale later, which you'll see. And then some details here, but we trained on Princeton's Adroit compute cluster for about 11 hours. So let's actually look at how the model turned out. Let's put this short video here. This is a street view of Australia, Europe, Asia, and South America in a 3D viewer. So not too shabby. Qualitatively, we looked at a few different criteria, structural coherence, whether or not the images actually looked like Street View panoramas, specifically if they were equirectangular, realism, how closely they followed the location prompt, level of detail, if there were any artifacts, and how well they generalized to locations that weren't in the data set. This is a image generated for North America. As you can see, it looks like a street view. The top and bottom, distorted, middle looks normal. If you put this in a 360-degree viewer, it looks normal. Detail, pretty good. Look at these branches here in the wispy clouds, not too bad. Definitely looks like an average street in North America to me, like pretty suburban. If you look closely at the houses, you'll see maybe some weird things, but overall, not bad. Yeah, and then this is Street View for England. I've never been to England, but it looks like England to me. There are some artifacts, but there are also issues with the training data itself, which we'll go over later. Thailand, again, looks very different from the past two generations. Cars look a little weird. The model didn't really learn cars or people that well, likely due to the low training resolution I mentioned before. That's something probably could be fixed in follow-up projects. Yeah, so this is kind of what I was talking about, right? India. Most of India generations have this weird blurry stuff at the bottom, which I was really confused by. But if you look at actual street views from India, a lot of them have this thing at the bottom for whatever reason, I don't know. So the model actually learned that, which is actually a good sign that we are learning from our training data, but it also is just a limitation of the study. The data was not perfect, but honestly that's fine because we weren't shooting for perfect images. We were more looking at whether or not we could have a diffusion model learn the properties of a panorama from just data, which it did, which is actually pretty impressive and super cool. So I was pretty happy. Comparing our model with other models, StreetView360X just has a much better kind of structural and visual coherence. Definitely looks very similar to the countries in the prompt, whereas Stable Diffusion has trouble generating kind of these 2:1 street views. They're 2:1 ratio images. They don't really look like street views. LDM3D had better properties in terms of being equirectangular, but this clearly just isn't the US. It doesn't have the location knowledge that our model does. Great thing about fine-tuning on Stable Diffusion is that you have all the knowledge of Stable Diffusion, so you're able to generalize outside of the data set. We did not have any images of Antarctica, yet the model is still able to learn pretty well, as you can see. Hogsmeade, fictional location, but this is what Hogsmeade would look like if you were there, I guess. You can also do weird things like combine Brazil and Japan, so if you ever wondered what a mix between a street in Brazil and Japan will look like, now you can do so. As I mentioned before, we generated at kind of a lower resolution than upscaled in some cases with a GAN called Real ESR GAN, but it's basically a generative adversarial network trained specifically for the task of upscaling images. And the performance is pretty good, although it does kind of lead to more of a matte, like less realistic effect, but good enough. Quantitatively, we evaluated the CLIP score and the FID score. The CLIP score measures how well do images adhere to their prompts. FID score measures how similar are generated images to real images of the same class. Our model beat the other two models in both tasks, so great sign. So yeah, both good qualitative and quantitative performance. In conclusion, I think we definitely captured the structural and visual properties of street views. They look great in 3D viewers. They look pretty realistic, and you can kind of tell. You can definitely tell differences between different locations, and you're able to generalize to locations that aren't in the data set, which is always something that you want, and it's a pretty good signal for the future applications of diffusion models to VR. Follow-up work could include looking into different models to different ways to train to get higher resolution images natively instead of having to upscale later on. Could work on, currently there's a seam between the left and right edges of images, which ideally you don't want, so there are entire papers dedicated to this topic, so that'd be a much bigger project to try to remove that. Training smaller models just based on specific regions might be interesting, like to train a model just on Princeton or New York. You could do a digital humanities study, just kind of analyzing the cultural or kind of geographic information from these images. I feel like that'd be really cool. And finally, kind of create like a web GUI or GeoGuessr type game to let people interact with the model. These are people I must thank for helping me throughout this process. Thank you for all your help, and these are some bibliography and links. I'll see you in the paper.